I don't know, a bunch of different shit.
Not the true definition. Yeah, not in the strictest sense. It's not a code. Now, information, again, when Shannon's talking about this, Shannon's talking about Shannon.
Yeah.
We're talking about entropic
Okay.
states. We're talking about the entropy of a system, right? And the entropy is the unusable energy in a system. In this case, how much is wasted? How much is lost by sending information through a noisy channel, right? When a noisy channel is you need more bits of information than you normally would use in a clean channel, right? Because of what's called entropy. And what I described even in my presentation, that for nucleotides, you need 2 bits of information, right? That's the minimal amount to convey information. But the code is the C, T, G, and A. The 00, the 01, that's not the code, right? The code is what I'm coding for is for the nucleotides. The information is just what it is to get to 0001. That information, that signal, and if you ever look at discrete signal processing between like a quad operational amplifier or any kind of electronics, you have a lot of signal processing, right? That signal processing, that information that's in those discrete systems is not ever called code. I've never seen code used in electronics that way.
So if you're looking at the Turing model, right? The computer, the Turing model. If you're looking at the Turing model, the computer is a ribosome to me. Like his computer is a ribosome. Nazi information, Turing's computer, output protein.
And the difference is that we designed a computer. We are the agent.
So it all comes down to that. This is why John brought that up, because it all comes down to, well, then that means there's a designer. Why does there have to be?
No, not necessarily. No, it doesn't have to be.
Well, then why can't it be a code? I'm so confused.
Code. Right? I mean, even if that's the case, even if you take the syllogism as is, right? It's not a very convincing syllogism because you're just doing it based upon descriptive definitions. Right? It's not a convincing syllogism at all.
Why is that analogy? Is that not analogous though?
No, because if I say I'm defining a word to mean this in my premise, I'm defining it this way, and so the conclusion is based upon that definition. Okay, great, but I can define it some other way, and it no longer works. Right? These are all
you understand why I can map those systems. Okay, go ahead.
Let me ask this question from the live chat real quick, just because I think it's prevalent. They asked, would it be, Steve, would you consider it fair to say that we have codified our understanding of DNA by creating a model that is represented in code? I think it's fair to say it's codified.
That's an analogy. Codify just means to have a specific set of rules, right? That's what codification means, right? If I codify something, I am writing it down and saying you have to obey these rules. That's what code is in that regard. So we have done that in that. And again,
John,
that's a codification because that's not what we mean by DNA is a code. DNA is not a legal code. It's not a codified system like that.
Okay.
There is a very specific set of rules that the ribosome uses with the chain of RNA. So the chain of RNA, the messenger RNA, that is the message. And the ribosome is using a very specific set of rules to read that message and output a protein. The code is written. Those rules are
since codes have
code on chart. The rules exist in the structure of tRNA. That's where they actually exist in the cell. But in a textbook, they're going to exist in the codon chart. The codon chart is what we use to show each other the code that governs the genetic system.
And here's can I respond?
Sure.
Yeah.
Hello? Okay.
Yeah.
So the difference is you're looking at a descriptive system. We're looking at something and we're describing what we're seeing. We're making the codon chart. Nothing about that's prescriptive, right? The rules of how things work do not have to obey that codon chart. It's that we look at that codon chart and we came up with the codon chart because we observed something. You're confusing descriptive with prescriptive. And for a set of rules in a codification,
you are wrong.
Hang on, I'm not wrong. That's prescriptive, meaning that I'm not wrong on this. Prescriptive means this is how it has to be. We're defining something to be the case that you have to obey a set of rules. That's prescriptive. Codon chart is not prescriptive. It's descriptive. It doesn't change the reality. If I change that codon chart, if I make something else, reality is not going to change. It's not prescriptive. That's the biggest difference I think you're missing.
The tRNA, the 3 nucleotides in a tRNA, and the tRNA that attaches to serine determine which 3 nucleotides in the messenger RNA can code for serine. They are determining that. They are prescribing that. It is the structure of the tRNA that's prescribing that.
Yeah, you're not understanding what I'm saying.
We are then describing it. No, I understand. We then described it by figuring out what the tRNA is prescribing, and we write that down as a chart. Okay, and our chart is a description of the actual rules that are governing the transcription system or the translation system.
That's not what prescription.
So you're right. You're right. We've got a chart that is describing a real thing that actually exists in your cells, a real set of rules that actually exist in your cells that are governing the communication system. Like, who are the rulers of that communication system? That would be the tRNA. They are dictating what that actual system is. They're the kings of it, if you want to say.
Rules that reality has to follow. We don't write the rules. No, nothing's writing the rules. They're from an evolutionary process that's coming out by emergent things. There's no directionality there. There's no direct communication in that system. It's all because of an emergent thing. There's nothing saying this has to be this way. As you even said, it's arbitrary. Prescriptive means that it is this way. We are saying it must be this way because we've decreed it to be this way. There's nothing decreeing it to be that way. It is that way because it's an emergent thing from evolution.
If you mutate a tRNA and change the genetic code by mutating it, the organism will die immediately. Well, as soon as the proteins that it produces fail.
I'm not saying that relative to what I just said.
Because this coding system is governing how our cells work.
So I was saying if it works consistently and accurately, like it consistently if the rules as we understand them continue to be adhered to, then it produces accurate genetic information that we're able to use to continue to survive. So it seems that this argument, if I'm not mistaken, seems to be hinging on whether or not it was created by somebody, and that's the only way something can be a code. So a code can be not created by. Steve, can you give me an example of a code that wasn't created by a mind?
If you remember that, you rewind the tape and you remember going in, I wasn't going to argue whether it required a mind or not. I actually said that at the very beginning for this very reason, right? I'm not going to argue whether it requires a code or not. I can argue if it does require a code, then it's this. If it doesn't, if it does require an intelligence, this. If it doesn't, then this. But I don't have a stand on it either way. If you want to use code as it requires an intelligence or not, it depends on what area that you're coming from. As simple as that.
But you'll excuse me if it seems like a lot of your arguments seem to kind of hinge on an intelligent sender and an intelligent receiver and an intelligent person.
Most of it does when it comes to things like a code. Yeah.
Yeah.
Most
okay.
of it does.
But but you won't give a definition of a code that doesn't require an intelligent mind.
I don't know any off the top of my head. If there are some, I'm willing to accept that, and it doesn't change my argument in any way.
Okay.
I'm not arguing natural codes. I'm not arguing that. There might be. I don't know of any, and I'm not concerned about that because it doesn't change my argument if there is.
Okay.
No, genetic code is one of many codes that was not designed. Yeah, it's one of many codes that was not designed. Again, communication systems and the rules that govern them throughout biology.
So, John, for you, a code is because there was lots of people in the chat, and I feel like I've been picking on Steve. Just because I like picking on Steve. For you, people have been arguing. People in the chat have been saying that essentially me too, because I understand better. That your definition is overly ambiguous, and it allows it to be translated to any time information is transmitted and received, then that can be defined as a code. And then that it becomes too easily overextended in those circumstances. Because what are all chemical reactions a code?
No, chemical reaction is not a code.
Okay.
Again.
Why?
So if you look at the codon chart, there are symbols. So the 3 nucleotides in the genetic code are symbols that represent an amino acid. They are symbols. In a chemical reaction, you don't have symbols. Okay. In the genetic code, you have real symbols. And again, is there a communication system? The definition of a code is a set of rules that govern a communication system. For a communication system, you need a sender, a receiver. You need to transmit that information across a channel. Like that was already described. The definition that I'm using is the definition that Claude Shannon uses, and it's the definition that gave rise to the digital revolution. This allowed people to realize that, look, we don't have to we can invent codes out of pretty much anything. We can have 2 machines talk to each other. We don't need an intelligent person to intervene. We can have machines talk to other machines if we have a code, a set of rules that governs that communication. They can talk to each other. This was a huge deal, and that's why Shannon is so famous among people that study computer science.
Well,
Shannons are awesome.
If I could say something real quick, I think you just kind of shot yourself in the foot by what you just said, because you just said chemical reactions are a code, but the process of the central dogma of biology, from DNA to mRNA to protein, that whole transcription to translation, is one big chemical reaction. It's one big exchanging of information of how to do conformational changes. It's physiochemical.
Yes.
That's why it's not that's again, chemical reactions are not a code. There's no code in that system. The code is what we interpret and we give it meaning.
No, you're wrong. So a chemical reaction is not necessarily a code. There are chemical reactions that govern everything. There are chemical reactions in the genetic code, but a chemical reaction is not a code. A code, again, let me just say this super slow, is a set of rules governing a communication system. So if chemical reactions are involved in that, that's fine. So reaction in and of itself is not a code.
To form water, those are obey chemical rules. That's code.
You have to repeat that. He had you muted. You have to repeat that. Yeah. Nobody just telling you that.
So the rules for like hydrogen, 2 hydrogen and oxygen coming together to form water, there's rules involved in that because it's a chemical process that must follow a certain thing. I mean, you put hydrogen and oxygen together in the right conditions and they form a water molecule. There's rules of chemistry that dictate that. That's a code?
No, because it's not a communication system.
It's communicating how to make the molecule.
No.
What's the difference?
It's not a communication system. There's not 2 entities that are communicating to each other. In the genome, there are 2 entities communicating to each other. No, it is not a communication system. I showed you a chart of a communication system in Claude Shannon's paper. I defined it very specifically. Why do you not understand this? You even watched me take my talk yesterday.
Actually,
I asked him that question like 5 times a day.
I've read his stuff, and I've actually had discussions with people who are PhDs on this that are disagreeing with you. So if I don't understand and they don't understand, I'm cool with that. But I've had
you did not talk to someone with a PhD in communications.
Understand his paper the way you do.
You talked to
two of them are geneticists. One's a biologist.
You talk to 2 biologists that don't understand
about
communication
DNA,
systems. Yes.
Yeah. If I'm
what are the 2 entities, John?
DNA, what's Shannon?
Okay. What are the 2 entities?
What are the 2 entities that are communicating with one another in order for that chemical reaction to not fit the qualifications of any other chemical reaction?
The genome is communicating by sending a message, by transcribing a message into RNA, sending that message, transmitting it through the cell to the ribosome. So you have the genome and you have the ribosome. These are the 2 entities that are communicating to each other. What are they communicating about? They are communicating about the structure of a protein. That's what they're talking about. Right.
So there's a purpose in the transmission.
Yeah. I mean, you're using teleological language, which a lot of people don't like using in biology. But yes, the